Hello everyone, my name is Ramba Mamba back at it with another video. In this video we're going over everything you need to know about Unity, including how to navigate the complex UI system in Unity. Basically this is a quick start guide to reach your goal of starting to make games. Before we get started, I recommend if you do not have Unity installed, you can watch the previous video, episode 0, how to set up and install. Of course, I'll have a link down in the description to get started with downloading Unity. Next, the music in this video is by my friend Darren. Uh, I'll have a link down in the description, of course. And lastly, we started a Discord server, which is a great community where you can hang out with other game developers and you can talk to them, make some games, do anything related to game dev and coding. So let's get started. So you've downloaded Unity and you want to get started making your first game. Well, we're going to want to open up our toolbar and search up Unity Hub. And basically, inside of the Unity Hub, this is where you can manage your projects, you can make new projects, you can do all sorts of things. So, first thing you can notice is that we have the projects tab. So, this is where you can add projects that you've, say, downloaded from online source code. You can make a new project using new. You can go to installs, and this is where you can manage all of your versions of Unity. So, you can see I have two versions installed on my system, and you can always add one and select a version of Unity. So periodically, you'll want to do this to get the most updated version of Unity. And inside of the projects tab, you can of course add and make new. Inside of the community tab, this is where you can get forums and the blog and all that stuff. And inside of learn, you can learn from articles from Unity itself. So this is a really nice place to learn something new. So we're going to get started with our projects tab, and we're actually going to create a new project by clicking on new. And now we can specify what type of project we want. So there's a bunch of them, but we will only be messing with 3D and 2D. And so as you can guess, these affect the dimension, and you can also give it a new name. So we'll get started with the empty 3D project, and I'll set the name to something like my first game. And you can also specify the location you want it. Pause. So let's go ahead and create this project. So then it'll take a couple of seconds to load up, but then it'll be loading up the Unity editor. This is where you can edit your projects and actually start making your game. Alright, so you've created your new project and now you want to get started using the new interface. So at the very top right, you'll notice that it says default, and this is where you can change all of your layouts. The layout controls the order of all of these little tabs that are everywhere, and you can make your own layouts and your own orders. For example, if I click on default and I change it to something like tall, which I personally prefer, we get a new layout. And in this layout, you can see that this box is smaller, the main view is a little bit bigger, and overall everything is just a little changed. So if I go back to default, you can see that the layout has changed again, and we can actually make our own layouts. So if I hold down, for example, the scene, if I hold it, I can drag it anywhere. And if I let go, this popped out. But if I drag it onto here, like like so, I can also expand it using this, like grabbing the edge of it. For example, if I really liked this layout, which I do not recommend at all, I could go into default and I could click save layout, and then I could give it a name, something like weird layout, and then I could click save. And so now if I ever wanted to come back to this easily, I could just simply click on weird layout and I'd be here. This is especially useful if you're doing tasks such as modeling and programming, and if you want to switch between multiple tasks very quickly. For example, one task such as having the scene view really big, if I drag this onto here once again, having a scene view really big would be helpful to create a new level. However, having the game view really big would be helpful for playtesting. So you could have multiple of these layouts for different tasks. So that's really helpful. I'm going to select the layouts and go back to default. And that's what we're going to be using for this video. Next, you notice that we have a bunch of these tabs, and you're probably wondering what each of them do. So the first thing that we have is this big square in the middle, and this is your scene. So what that means is that this is where you will be making most of your game. This is where all of your objects in your game are going to be visible. And this is kind of like a movie set. This is not exactly how it's going to look in the game, but this is all the props and stuff you have. Next, at the very top, you can switch tabs to the game tab. And inside of the game tab, this is what your game will actually look. This is what the movie will look, not the movie set. And obviously, if you hit the play button at the top, we will be able to perform all of the actions that we intended in our game. Speaking of which, if I hit the play button right now, if I hit it, we are currently in our game and nothing actually happens because we haven't programmed or added anything. We can also click the pause button, and we can also continue press the step button to move frame by frame. Next, inside of the game view itself, we have a bunch of these functions. We do not need to worry about these three, but over here we have maximize on play, which basically means that just the game view will maximize to the entire screen. Next, we have mute audio, and this will mute audio. And lastly, we don't need stats, but Gizmos actually makes it so that your game view becomes kind of like your scene. So in my scene, I can see my camera itself, and I can see my light source if you look. In my game, I don't see that because that's not exactly how it's going to look inside of the actual game. However, if I turn on gizmos, I'll be able to see the camera and the light source. So we will keep that off and we will not mess with that, but that's just something to keep in mind. Next, at the top left, you'll see that we have these many tools. We have first the hand tool. And so if I click on the hand tool and I go into my scene, not my game, I can move around, which is really cool. And with the right click. And if I press left click and drag around my mouse, I can look around. So using these two, I can move my camera up and down, and I can look around. I can rotate around. So this is really helpful. I can also use the scroll wheel on the mouse to zoom into objects. So with a combination of these, I can move to line up with the camera. I can zoom in, and I can kind of look at it in the center. Next, we have the move tool. So if I select this move tool, I can actually select any object. For example, if I select the camera now I get these three arrows and I can actually move the camera in any direction I want. So I'll press Ctrl Z to undo all that. So it's back to where it started. So that tool is very helpful. Next we have the rotate tool. So if I click on the rotate tool, I can click off of this object by clicking away. But then if I click on it again, you see this kind of UI, and we can use it to rotate the camera or rotate any object really. So I'll just Control Z it to undo it again, and we can rotate on any axis, and you can see the result in the game. So for example, if I rotate this camera, let's rotate it almost sideways. You can see that this is our game camera. So whatever output we have in our game will be displayed from this camera. So now if I click on the game, you can see that the camera is actually tilted. If we go back into our scene, we can reset the position of this just using Control Z. There you go. And lastly, we have the scale tool. So if I select any object once again, we get these three boxes, and I can scale it on different axes. And if you click on the middle gray one and scale it, we actually scale the entire thing evenly, proportionally. So I'll just undo everything. There you go. And you can see that they didn't have any effect on the camera because it was just an imaginary object. We don't actually see the effect of it. But if we place something like a cube and scale it, then you'll see it. You'll see the changes. Next, at the bottom, we have our project tab and our assets. So we'll go over this in more depth later, but inside of the assets folder, assets area, this is where you can manage everything that you import into your game. For example, if I found um, a really cool person, 3D model of a person online, I can download it and I can import it into Unity. And this is where it will show up. Lastly, we have our inspector on the right hand side. If I do not have anything selected, for example, if I click off anything, nothing will show because this inspects objects. So if I select on my camera, we get all of these information. And this is just information about the camera. It looks really complicated, but when you look at it, everything is very easy to understand. First, it says its name. So right now it is named main camera, and we have a tag and a layer. So these are not important for us right now, but they just help with the organization of some parts. Next, we have transform. So you can see that it's a component because we can minimize it, and all of its data is like minimized. So inside of this transform, we have position, rotation, and scale. Basically, transform is responsible for all of the position, rotation, and scale. And right now you can see that its position is at 0, 1, and -10, and its scale is at 1, 1, and 1. Next, we have a camera component, and this controls everything about the camera. For example, its clipping panes, its viewpoint, its depth, a bunch of features. Lastly, we have an audio listener, and this just makes it so that it can also capture audio as well as footage. You can notice that none of this is really important to us. However, we have this add component button, and using this we can add our own components, such as I can add any component. For example, even on a light source like directional light, if I zoom out of my scene and I click on my light, we can add a camera component. So we can add a camera to our light, but that's not really useful. But for example, if on our camera we wanted to make it so that it would uh, flip around 180 degrees every time we press the button P, we could do that. We could add component and we could make our own script, our own code to do that. Custom effect. And so, lastly, in order to navigate around the scene, not only can we use the hand tool and left click, my bad, to kind of look around, we can also press on the middle mouse button and hold it down from any tool. For example, if I'm even on the scale tool, I can hold down the middle mouse button and still look around. And if I right click, it will always be a look around. You can also look around using these what is it, three dots? Or I don't really know what to call it. Also, if you click on the cube in the middle, you can see that we switch between perspective and isometric. So isometric makes it so it's like flat. This is useful if you want to make sure things are lined up or something like that. But if you click on again, you'll be on perspective. We want to be in perspective. Lastly, we have our hierarchy. This is where most of your stuff is going to go down. So inside of our hierarchy, we can see sample scene. Remember how I told you that it's like a movie set? Well, there's scenes in Unity, and each scene is kind of like its own separate movie set. Right now, we're in the default scene called sample scene, and underneath there are all the objects within the scene. We have a main camera and we have a directional light. We can click on each of these objects. For example, I can click on the main camera and we get the inspector, and it's basically the same as just clicking on the camera inside of the scene. We also have the light, so if I click on the light and if I double tap on it, it'll actually move towards it. And now if I click it, we have the inspector for the light. Now that we know how to navigate around Unity, let's get started by making some of our own custom objects. So if I go into my hierarchy, remember this is where we can make our objects. We can right click and then we can click 3D object and we can move to cube. And now if I click on cube, now you can see that in the middle of our screen we have a little cube that appeared. Once again, we can right click and you can see we have a bunch of functions like copy, paste, but we can also click create empty 3D object. We can add 2D objects, we can add effects, lights, videos, audios, UI, and cameras. So let's just create more 3D objects. So if we right click and then go to 3D objects, we can add something like a sphere, for example, now. And you can see they're within each other, but that's okay. And now if I click on the cube, you can see that its position is at 0, 3, 0. And we can either change this by moving to the move tool and then moving it back to its position. However, we won't be exactly on the spot that we want to be at. We can actually go into the transform and manually change these values. So if I click on 1.09, I can type in 0, 0, and 0. So now we're at perfect center for this. Let's click on our circle, our sphere, and let's set it to 0, 0, and 0 as well. And now, using the move tool, which we have selected, which is the second one, we can move it up. And now we have a sphere sitting on a cube. And I'm moving around this scene by holding down the middle mouse button to look around the scene. Now you may be wondering, how can we move between the move tool, the look tool, and all of these so quickly? Well, we can use some shortcuts. So the first shortcut is W, and if you click on any object, and if I press W, I'll move towards the move tool. So now I can move objects. I'll press Ctrl Z. If I press E, I'll switch to the rotate tool. If I press R, I'll switch to the scale tool. And if I press T, Y, and U, we won't be needing those, but those are advanced shortcuts for the other three items that we didn't talk about. And of course, you can press W or Q to go to the hand tool. Now that we know about creating objects, let's move on. So let's go ahead and delete both the ball and the cube. So we can either select inside of the scene by selecting them and then simply doing delete, or we can select them in the hierarchy. So I'll just select the cube and I'll delete. So now let's make a player and let's make some sort of map to make a simple platformer which the player can jump between the platforms and complete each level. And of course you can expand on this, but we'll be doing a very basic tutorial. So we'll also leave the light in the scene, but we'll make sure to delete the main camera since we want the camera to be with the player. So I'll go ahead and delete that. So now our scene should be empty with just the directional light. And I will go ahead and go to file and then I'll save just to make sure that it's saved. So next I'll create our player. So if I right click inside the hierarchy, I can create a 3D object and I can create a capsule. And so if yours isn't at 0, 0, and 0, you can go to the right hand side and change the position of it to 0, 0, and 0. And the rotation should be 0, 0, 0, and the scale should be 1, 1, and 1. Next, we can go ahead and create a camera for our player. So we actually want this to be a child object of our player because we want the camera to follow the player exactly how it goes. So if I select our capsule while it is highlighted blue in the hierarchy and then right click right on top of it, I can go into camera and I can add a camera. So now you'll notice that we get this little arrow, and we can hide it. We can hide all the child objects, and we can notice that if we move our player, we also manage to move the camera. So I'll just undo that. I'll also be renaming the capsule. So if I select the capsule, and then on the right hand side in the inspector, I can rename it to something like player. I'll also take the camera, so I'll select the camera, and using the hotkeys we know, W, E, R, with W selected, I'll raise up the camera, and I'll also make sure it's at 0, uh, whatever value you raised it up to, and 0. And so now you can see that when you hit play and it goes into the game mode, we see out of the camera of our player. So now we can undo the play. So now we have a camera and we have a player. So now we can make some sort of simple map for a player. So I will hide our player, and I'll right click inside of our hierarchy, and I'll create a 3D object, and this time I'll be creating a cube. So I'll also position it at 0, 0, and 0 if it already isn't. And then with W selected using the hotkeys, I will actually lower it so it's underneath our player, just like that. And then I'll also be changing the scale. So if I press R on our hotkeys, and then I can change the scale on the y-axis to kind of make it like a thin platform. And then I can increase the scale on the x-axis and also the z-axis to kind of make like a platform, you know? So now I've got a platform that looks nice. And I'll actually duplicate this by pressing Shift D, or Control D, my bad. And then if I press W to go back to the move tool, I can move this platform and I can kind of make a map. So again, I'll select one cube, I'll press Control and D, and then with this new cube selected and with my move tool selected, I will offset it, and I'll simply repeat this to make a simple map. So I'll do this again, and maybe this time I will move it to the right and move it a little closer so it's an easier jump. So there we go. Now we have a simple map. So if we hit play, we should see the platforms that are in front of us. And now we can get started with moving the player and also making our camera be able to move and look left and right. The first thing I'll do is I'll select our player, and I'll be adding a rigid body. So with the player selected, and if I go into add component, I can add a rigid body. So a rigid body is responsible for all of the physics. And if you hit play right now, you'll notice something very interesting. And you actually might not notice it now, but if we collide into any objects, we'll start flopping around and we'll fall like a normal physics object would. So we can actually go into the constraints tab of our rigid body by expanding it, and I can freeze the rotation on the X, Y, and Z. Don't worry, this won't do anything. This won't do anything bad because we will be controlling our movement using transform.translate, which is what I'm about to go into next. So make sure we have the rotation frozen on the X, Y, and Z axis. Now we can add another component on our player. So I'll select add component, and this time I'll search up script. So I'll select new script. Now we can name it anything. So I'll name it something like player movement using camel case. Now we'll wait for this script to kind of load up. And then you'll notice inside of our assets folder, uh, you'll actually get this little green script section. So if we double click on this, it should open up in Visual Studios. So basically what we added was a custom power to our player, a custom script that will kind of control our player however we want. And so we'll use this to control the player's movement, of course. So this might take a little while to load up. And mine has loaded. So you might think this is just a bunch of jumble of letters, and it is really confusing, but everything has some sort of meaning. So at the very top, we have these using statements, and this basically is irrelevant to us, but this means that we are able to use code for Unity Engine. And so if you go into harder code, you might be using stuff like using Unity Engine.scene management, which gives you some extra code snippets you can use, extra functions. And then right below it, you'll notice public class, player movement, mono behavior. And what this basically means is this is everything that is underneath this bracket and that is between the end of this bracket is part of the code that you just made. And a class is kind of like a script. A class is the group of code that you made. So remember, everything that is between this bracket and this bracket. Next we have void start, and it gives us a message saying that it is called before the first frame. So this is the first thing that happens when this script is played. And again, anything that is between this bracket and this bracket is part of void start. Next, we have void update, and this happens every frame. So this was happening really, really fast. You would use this for any movement or anything like that. And we have one bracket here and one bracket here, and anything between it is part of void update and will happen every frame. So for our situation, we would like to make player movement. And we would like to do that using by getting the player's input on the horizontal axis, the vertical axis, and then actually moving our player to it. And we would like to do this all in void update so that the player is constantly able to move. We don't want it so that the player can just move the first millisecond. So that would be void start, but we want this to happen every single frame. So at the very top, right under our public class and under this bracket, if we hit enter, this is where you make all of your variables. So a variable is something that you can use to store some sort of data. So in our case, we will be creating one variable that stores speed. So I can simply type in public float speed and set it to 5. So the many things that are happening here is that we first say public. This defines the reason we say public is to say that, well, it's a public variable and it can be used anywhere. Next, we say float. So this is the type of variable we want to create. There's many types, such as string. We have boolean, bool, which can be simplified to bool, which is how you write it. We have integer, which is int. We have double. And these are all types of variables. For example, a string is a word. For example, it could be Ramba Mamba. A bool is something like true or false. Oops. It's true or false. An integer is a number like 1, 2, and 3. And a double is, well, I forgot what a double is actually. But we won't be really needing those. A float is basically just an integer, however, it can have decimal points. So we could have something like 1.2 as a float. So we made this variable to store what our speed is, and this can be changed by the person who is making the game, obviously, and this will decide how fast the player moves. Next, we'll be making another variable called a vector2. This time we'll be creating a private variable because we do not want this to be visible inside of Unity, and we do not want this to be visible for anyone to use. This needs to be private and just within this script to be usable. So we'll call it private, And the type that we want to make is a vector2. And then lastly, the name we want it to give is velocity. And lastly, we do not want to specify a default value, so we'll just not put an equals and that. So now you might be wondering, what is a vector2? A vector2 and a vector3 are both very similar, but basically what a vector2 is, for example, if you had a coordinate plane, any given point on that coordinate plane has an x value and a y value. That would be its vector2 value. And then we have a vector3, which is its three-dimensional space. We have the x-axis, the y-axis, and the z-axis. For example, from the origin, if I drew a graph, something could be at the point 1, 1, 2, 2, and all that. So a vector2 can be expressed as x, it can be expressed as x, y, two values. So for example, we could have something like 1, 2, 3, 4. And this is just a way to store some numbers in a certain data format that we want. And so this will be very helpful to decide in the x-axis how much we want to move and how much in the z-axis we want to move. So we can actually delete void start because we will not be needing that. Because remember, we want the movement to be happening every single frame. And then inside void update, we first want to get the inputs of the player, and then we want to set the position of our player. So we can change what we have stored inside of velocity. So we could do velocity dot x, and remember, velocity, which is this variable that we made, is like an x and a y value, right? So when we say velocity.x, that means we are changing the x value, or the first half of this vector2. So velocity.x is equal to, and now we want to get the input of our player. So we would do input.getAxis, and now we would say what vertical or horizontal we would want to get. So we would want to get horizontal for x, so horizontal. And now we would multiply it by our speed. So we could simply do the star symbol, and then we can do speed. And lastly, we would want to multiply by time.delta time. And so what time.delta time is it evens out the frames. So for example, void update happens every single frame. And if I was running this on an extremely fast computer that could do hundreds of frames per second, then what would happen would be that the player could move extremely fast compared to someone that was running on a slow computer. So we want to even this out by multiplying it by time.delta time. This is very important. So again, what we're doing here is we're setting the velocity.x to our input on the horizontal axis, which is a, d, left arrow, right arrow, and then we multiply it by our speed. And now we would simply do the same, so I'll copy this, and I'll change it to velocity.y, and we want to get it on the vertical axis and multiply it by speed and time.delta time. Now that we have our inputs, for example, we have velocity currently looks like if the computer was to look at this, velocity looks like horizontal movement, vertical movement. And remember, when I mean horizontal movement, I mean left, right. And when I talk about vertical movement, I talk about forwards and backwards. So now if we would actually want to program that, we would simply say transform.translate And what transform means is transform means to get the current object that the script is on. So this is on our player. So we get the position of the player and then we change it using translate. And now we just simply need to say where we need to change it to. So to move on the X, to move forward and backwards, that would be velocity.y, and to move left and right, that would be velocity.x. So we would want to do velocity.x, and then we would do 0, because we do not want to be controlling the up and down. And then to be moving forward and backwards, that would be velocity.y. Now we can delete all of this. And if we save, we should be able to move. So if I go back into Unity and wait for the script to complete compiling and loading and all that stuff, if I go back into our player, we are able to see speed here, which is set to 5. So now if we hit play, I should be able to move forward, backwards, left, and right nicely. That's awesome. Perfect. Now let's add a camera look so that we can look around with our camera. So I'm going to go into File and I'm going to save. And then I'll go back into our code and I'll also make sure that's saved using Control S. Now we would like to create a new script. So if I actually expand our player and I select our camera, I'll add a component on our camera and I'll call this camera look. I'll create and add this. And I'll give it a second to finish creating, and then I'll double click on it and I'll open it up in Visual Studios. Alright, so what we want to do for camera look is if the player decides to look left and right, we would like to turn the entire character like you would in real life. But if the player decides to look up or down, we would only like to move the camera and rotate the camera. So again, if I go into Unity, we can create a couple of variables. First, we need to get the position of our player. So we can do public transform player. So the reason we say transform is because we want to get the position, the rotation, and the scale of the player. Next, we want to make a variable for ourselves that would keep track of the rotation on the y-axis. So I'll make a private variable for this since we do not want it to show up. And I'll make a float type, which again is a decimal, y-rot. And lastly, I'll create a sensitivity variable, and we want this to be public so that the player can change it at a later time. So public float sensitivity, and I'll set it to a default value of 100. So I'll save that. And now if I go into void update and add a couple of spaces, remember everything between this bracket and this bracket is part of void update. So the first thing we would like to do is get some variables and figure out the input on the mouse. So I'll do a new float. So float mouse x, which is the mouse on the x-axis, and then I'll set it to our input, and we would want to get axis mouse x, and then we would like to multiply it by our sensitivity amount, and then again we would like to multiply it by time.delta time. So this is very similar to how we did movement. This is just with the camera, and again I'll change it from mouse x to mouse y. So now we have two variables that figure out exactly where our mouse is and how much it's moved. So now we simply need to set it. The first thing I would like to do, however, is I would like to flip our rotation on the y-axis, since many games actually flip it on the mouse just so it's easier, and you might be actually used to it being flipped, so I will do that. So y rot, you can try with and without, but I'll be doing y rot is minus equals mouse y. So our y rotation is now flipped, and now we would like to clamp it. So what this means is that we would not want our camera to be able to turn 180 degrees fully. So I'll do something like y rot is equal to mathf.clamp, and now we can tell it what we want to clamp, and we have to give it the minimum and the maximum. So I'll tell it we want to clamp y rotation, and we want to clamp it at 0. Yeah, we want to clamp it at minus 90 degrees and 90 degrees. So now we know how much we want to move on the y-axis, and we can simply just set our camera to this. So if I say transform, this means that we are changing the camera, because it is transform with a lowercase t means that it's talking about the object that the script is on, and this script is on our camera. So if I say transform dot local rotation is equal to quaternion dot Euler, and I don't really know what quaternion dot Euler is, but that's just how you do angles. So now we can tell it what angle. So we would like to do y rotation, and then 0, and then 0. Lastly, when we are turning left and right, we would like to turn the entire player, not just the camera. So we can just do character, or player, my bad, that's what we call it. Player dot rotate, and then we can tell it vector 3 dot up, and we would like to multiply it by our x-axis movement. So now if we save, go back into Unity, and if I select our camera, we can see that we have our script on the right hand side named camera look, and it's asking for a player, and it's saying sensitivity. So you might see on player it says none transform, and for this I will make sure the camera is still selected. I'll hold our player, and then I will drag it into this slot that says non transform. So now if we hit play, we are able to look around, and we are able to move. But we can't jump, and the mouse is just not centered at all. So I'm going to save first, and then inside of Unity I'll add this very important line inside of void start that says cursor.lock state is equal to cursor lock mode dot locked. So this basically is saying that lock the cursor to the center of the screen so that it doesn't go flying around everywhere. So again, I'll save, go back into Unity. If I hit play, now the cursor isn't visible anymore. It might be visible to you guys since I'm recording, but I can look around and I can move. I just can't jump yet. So let's do jumping. The way we can do jumping is using a rigid body function. Remember, a rigid body controls all the physics, and we can add a kind of like a force to the bottom of our player and shoot him up a little to do the jumping. So I'll actually go into my player movement script, and then in void update I'll create a new and I'll create some extra lines, and then I'll simply do if, which is asking if something happens, do this. So inside of the if statement, I'll put the two brackets and I'll say if input dot get key down, and then I'll put brackets and I'll say key code dot, and I'll say space. And then I'll put my closing bracket. What this is saying is if the user presses and presses down the key, the space key, then we'll be performing any action that is between this bracket and this bracket. So within here, I'll say rigid body dot add force, and we'll add it up. However, we don't have a reference to the rigid body of our player. So at the top, I'll say next to our variables, we'll make a reference to that. So public rigid body RB. And then if you press space, then I will do something like RB dot add force. We can simply add a force of vector3 dot up, and then we can multiply it by something like 300. So now if we save and make sure to add this semicolon at the end, if I press Ctrl S, go into Unity, it is asking for what RB is. And remember, at the top, right above our player, we created a rigid body. So if I select my rigid body, I can drag it into this slot that says RB. Remember, this is because we created a public variable at the top named public rigid body RB. So now what we're saying indirectly is that this rigid body right here that controls the physics of our player is actually what we want to control when we add a force. So again, now if we hit play, we can still look around and move, and we can also jump. But here's the problem. We can double jump, and we can triple jump, and we can just jump over and over, even though that's not realistic. You can't jump in real life over and over. However, we do have a little platformer game already, which is really cool. However, you can just jump many times and just kind of break the game. So a way to fix that is what we can actually do is we can say in our code, if we are not touching the ground, do not let us jump like real life. So let's do that next. Let's go back into our script and let's make a reference to a couple of variables. The first being a transform, so public transform, and we'll call this ground checker. And we will use this as a position that from this position we will check if the ground is near it. So this will be put at the base of our player. Next, I'll make a public layer mask to define what the ground is. And lastly, I'll make a public float, which is again a decimal to specify the distance from the ground checker to the ground we want to check. So public float ground check distance. So now in void update, we can simply check if there is a ground, which is in this variable, from the ground checker within the check distance, then allow you to jump. So let's make a new variable, and I'll actually make this private since we do not want this to show up in Unity. Private bool, and it will be is grounded. And in void update, we can simply do is grounded is equal to physics dot raycast, which is an invisible laser that we shoot. And now we can say if we shoot a raycast from our ground checker into our ground within this distance, then is grounded will be true. So we just simply will just code that. So physics.raycast, and we'll say ground ground checker dot position, and then we will say the direction. So ground checker dot up, and I'll put a negative sign. So this means ground checker dot down. And then we have to give it the max distance, so check distance. And lastly, we just need to tell it what layer mask we need to check in. So that will be ground. Alright, so now when we hit space, we simply also want to check if we are grounded. And we can use this using the and keyword. So if I simply say and, I'm able to put two if statements together, and they both have to be true for whatever is underneath it to occur. So here we check if you press space and you also is grounded is equal to true. And over here, I'm actually using a doubles equal sign because this a doubles equal sign is used to refer to comparing. We actually don't even need this since when you say is grounded, it automatically is talking about the true. And if you say not is grounded, you're talking about false. So I'll just leave it. So now if I save, go into Unity, we need to create that variable that we made that would store where the ground checker should start. So I'll actually expand our player. I'll highlight our player so that it's blue, and then right click and create an empty game object. And I'll make sure it's at 0, 0, and 0. And I'll also rename this ground checker. So this will be used to check if the ground is near. And then I'll simply drag it down to the base of our player. Right there seems good. At the very base of our player. And I'll actually increase it a tiny bit. Perfect. And then on our player, under our script, it's asking for a ground checker transform. And we can simply drag in our ground checker. And now it asks for a check distance. So I'll set this to something like 0.4. We might have to adjust this. And then for ground, I'll change ground to a layer. And so we can create layers by actually, if I select one of the cubes, at the inside of the layer, I can add layer, and I'll add the layer ground. And then for each cube, I'll go in and make the layer ground. So I will repeat this process for every single ground that we have, all the cubes. And now that these are all grounds, if we hit play, it shouldn't, right now it does not let us jump. And I think that is because our ground checker is too low. So we can actually select our player. I'm going to just escape out of it. And I will increase and decrease this ground check distance and see if it makes a difference. And oh, I actually found the problem. Inside of our player, we need to specify what the ground is. So we made our layer ground, but we need to assign it. So if we go into our player and then our player movement script for ground, we can select the drop down and select ground. Now if we hit play, and you might want to play around with the check distance, but you can see I'm not able to double jump until I come in contact with the ground again. So now we have a complete platformer. Obviously, there's still a lot more you can add to it, and obviously you can add like moving platforms and all that jazz. But for now, this is a great start. Thank you so much for watching. I hope you enjoyed this tutorial. If you did find it helpful, it would mean a lot to me if you go ahead and leave a like rating down below and hit me up with a subscription and turn on those post notifications so you always know when the next video is dropping. And I always post all my content on my YouTube channel for 100% free, so it would be awesome if you could subscribe. Also, if you have any questions, be sure to check out my Discord. First link in the description. I will also be posting all of my models that I personally model and a lot of game assets like music and all that to make your game awesome. And I will be posting all of those inside of my Discord. So if you would want them, go ahead and join that Discord. and it's a cool place to hang out with other game developers. It's just a cool place to be. So go ahead and join. Thank you for watching. Hope you enjoy.